The following video production is designed to provide reasonably accurate and authoritative information regarding the subject matter covered. However, you should understand that all variables posed by on-the-job application of this information cannot be covered in this abbreviated format. Therefore, other or additional safety measures may be required under particular circumstances.
For hundreds of years, silicosis has been a serious occupational health issue for workers in mining, quarrying, stone cutting, stone grinding, and other occupations where crystalline silica dust is generated. In fact, silicosis was first identified in 1705 by Bernardino Ramazzini of Italy, considered the founder of occupational industrial medicine, who noticed sand-like substances in the lungs of stone cutters. While most of the stone cutting in Ramazzini's day was done by hand, the incidence of silicosis grew rapidly years later when industrialization was added to the mix, as you can see in these early U.S. Department of Labor movies. Today, silicosis, which can be disabling and debilitating, is the most common occupational lung disease worldwide. It is especially common in developing countries, where modern control technologies are not fully deployed, afflicting millions of workers. According to the World Health Organization and the World Labor Organization, which held a summit on elimination of silicosis in 2003, these are some of the sobering statistics for industrialized nations. In the United States, 1.7 million workers are exposed, and about 10% are at risk. In Germany in the 1990s, 3,000 new cases were diagnosed annually. In Japan, 1,000 new cases were reported yearly. In Australia, more than 1,000 cases are predicted annually. In France, there are about 300 new cases diagnosed annually. In developing countries, there is an epidemic of silicosis. In China, 10 million people were exposed in 2002, with 5,000 deaths reported. From 1991 through 1995, it's estimated that there were 24,000 deaths from silicosis each year. In Brazil, 6.6 million workers were exposed to silica dust. In South Africa, there were 600,000 accumulated cases among miners. Obviously, silicosis is not something you want to get. But you work in an industry where it is preventable if you and your company take the proper steps to avoid overexposure to dust containing silica. Dr. Peter Mazzone is a specialist in pulmonary and critical care medicine at the world-renowned Cleveland Clinic. He says silicosis is developed by the victim inhaling very small, unseen particles of crystalline silica. The particles travel very deep into the lungs, where they get lodged and cause some inflammation.
Like most places in the body, inflammation can ultimately lead to some scarring. And if you get scarring deep down in the lungs, then that can lead to breathing difficulties. Many people develop silicosis that we only see on a chest x-ray, that never really bothers them with symptoms. However, when symptoms do develop, the most common ones would be a cough and shortness of breath.
Dr. Mazzone says that the most common form of silicosis requires prolonged exposure to crystalline silica, which in the natural stone industry comes primarily from cutting or grinding granite, slate, or other quartz-containing materials without the proper controls or personal protective equipment.
However, there are situations in which you can get a very short-term but high-intensity exposure that leads to disease much quicker.
Short or long-term, those who get scars in their lungs can get very, very sick and develop shortness of breath that limits their ability to maintain normal activities or, in a worst-case scenario, maintain life. Symptoms of silicosis manifest themselves depending upon the severity of the disease, but can include fever, cough, weight loss, loss of appetite, severe breathing difficulty, trouble sleeping, chest pain, and nails with a bluish tint. There are 4 types of silicosis. Chronic, which, as Dr. Mazzone says, can come after 20 years of exposure. Asymptomatic, in which early cases of the disease do not present any symptoms. accelerated, that develops 5 to 10 years after high exposure to silica dust. Symptoms include severe shortness of breath, weakness, and weight loss. And finally, acute silicosis, which develops a few months to 2 years after exposure to very high concentrations of silica dust, causing disabling shortness of breath, weakness, and weight loss, often leading to death. Unfortunately, there is no cure for silicosis.
The best treatment is prevention, so that's avoiding the exposure. Once the aggressive form of silicosis happens, the scarring in the lung progresses, we do not have any effective medications to halt that.
So there's the long and short of it. Silicosis is incurable, but it is preventable. And that is the focus of this program, showing owners, managers, and workers in the natural stone industry how to prevent silicosis in the workplace, preventing disability and death. Preventing silicosis in the stone industry, particularly in those facilities that cut granite, slate, or other quartz-containing materials, must be a team effort. Obviously, it is the responsibility of ownership and management to provide the necessary systems that rid crystalline silica from the air and the personal protection equipment for the people who man cutting and forming machinery in the shop and perform hand finishing operations. Likewise, the associates operating the equipment have an obligation, for their own safety, to use these safety devices to the fullest. Obviously, in a perfect world, the secret to eliminating silicosis as a threat would be to eliminate the unseen crystalline silica dust. Easier said than done. The industry and its vendors have made great strides in this effort, but there's still a long way to go. One of the best methods to reduce the silica dust is through wet cutting and grinding. Wet cutting and grinding has been gaining in momentum during recent years. For instance, in a recent survey of fabricators belonging to the Marble Institute of America, 73% of the respondents said that their shops ranged from 90 to 100% wet. Another 8% said that they were 80 to 90% wet. The residual dust from cutting and grinding wet can be removed with new state-of-the-art water treatment systems, some of which remove the dust from the water and compress it into cakes for later disposal. The system then recycles the water so that it can be returned to cutting, grinding, and polishing operations. This system virtually eliminates disposing of waste materials into local sewer systems, and because it recycles the water, significantly reduces the amount of water consumed in the plant operations. There are also powerful air purification systems which extract the crystalline silica out of the air and deposit it into disposable cartridges. These too can be very effective. Either one of these methods, wet cutting with water treatment or airborne dust collection, can virtually eliminate the threat of exposure to airborne crystalline silica. In the United States, the Occupational Safety and Health Administration, or OSHA, has done quite a bit to address the silica situation. More than a decade ago, OSHA started a special emphasis program, which is an enforcement program that targets enforcement at establishments where there are high exposures to crystalline silica. Bill Perry is Acting Director of Standards and Guidance at OSHA headquarters in Washington, D.C.
Fortunately, there's no national disease surveillance program for silicosis. However, a few states have conducted such surveillance programs and generate statistics that we can use. A few years ago, there was a paper published based on those statistics where the investigators estimated there could be between 3,500 and 7,000 new cases of silicosis that occur each year.
In accordance with the OSHA standard for air contaminants, employee exposure to airborne crystalline silica shall not exceed an 8-hour time-weighted average limit. Or if a state-administered OSHA plan is in effect, the limit set by that state agency is used. Perry says that there are a few hundred deaths per year in the U.S. where silicosis is identified as an underlying or contributing cause. OSHA's current standard for crystalline silica, as described above, is an exposure limit on respirable dust containing crystalline silica. Respirable dust is made up of small particles that cannot be seen with the naked eye. These are the particles that can get deep into the lung and which cause the greatest potential for disease.
The limit is a formula, which is 10 milligrams per cubic meter divided by the percent quartz plus 2. So for example, if I have a material that has 8% quartz in it, To apply that formula, I take 10 divided by 8 plus 2, which is 10 over 10, or 1 milligram per cubic meter of respirable dust in the air. That's my exposure limit that I cannot exceed.
If the quartz content is 48%, the respirable dust limit is 0.2 milligrams per cubic meter. Wet or dry, Perry says there is only one way to determine the rate of silica exposure.
OSHA currently does not have a specific requirement to conduct air monitoring, but air monitoring is the only way to be sure that you are in compliance with OSHA's permissible exposure limit for crystalline silica.
The OSHA official states emphatically that you can't tell what employees are exposed to without exposure monitoring, even in shops using predominantly wet methods. He says that the use of the wet method should reduce dust levels compared to grinding or cutting dry. But he adds that there are a lot of factors that influence the levels that are going to result from a particular process.
How the water is applied, the rate at which it's applied could influence the amount of dust that escapes from the process.
If your company is using a dry ventilation system, the issue is making sure that the system is set up properly and pulling enough air through to filter the silica out of the air. The bottom line is that only with professional air quality monitoring can you establish a benchmark for the air quality in your shop, whether you employ wet processing or dry processing. Many health and occupational health organizations offer free air quality testing. If that isn't available, there are also numerous qualified private laboratories which can handle the job. No matter where you are located, in the United States or elsewhere, it's important to use the same method that the government uses to monitor air quality. Many methods are available, but the government's are mandatory and legally enforceable. And regardless of method, the first assumption made is that since no measurement has been established, a health hazard may be present. Therefore, it's necessary for employees to wear respiratory protection until air quality has been sampled and safe exposure levels have been verified. In the following demonstration, the plant in which this was filmed had already passed inspection, and respirators were no longer required. In monitoring air quality, OSHA uses breathing zone sampling to measure what the employee is inhaling.
It doesn't matter what's over in that corner if nobody's working there. What matters is what's getting into their lungs.
The OSHA procedure is called respirable sampling. Personal sampling pumps are used to measure the air where people are working. But before the sample can be taken, the equipment must be calibrated outside of the area in which it will be used. This adjustment makes sure that the monitor is pulling through the right amount of air. The personal monitor is required for particulate sampling, but it can also be used to measure gases and vapors depending on the type of filter used. Basically, the sampling systems consist of two components: a personal sampling pump, which is a small battery-powered vacuum pump, and a collection media or filter on which the silica can be collected. Two types of media are commonly used for industrial hygiene: sampling sorbent tubes and filters. Filters are required to measure particulates such as silica. In addition, since the silica standard is based on respirable dust, a third component, in this case a cyclone, must be used to make sure that only the respirable part of the dust is collected on the filter. The pump is attached to the worker's belt, either behind his back or above his hip, using a belt clip on the pump. The cyclone and filter, supported by a holder, is clipped to the employee's shirt collar in his breathing zone. The holder is attached to the air inlet fitting on the pump with a short length of plastic tubing that is run behind the employee's back. The combination of pump, cyclone, and filter is called a sampling train. When the pump is turned on, it pulls air through the cyclone where heavier, non-respirable dust falls out. Lighter and smaller, or respirable dust, is collected on the filter in the same way that the air filter in a car collects road dust. The filters look like very thin plastic discs with the consistency of stiff tissue paper because the filters are so delicate. They're placed in a small plastic cassette to facilitate handling. The cylinder has openings on both ends. One end is connected to the pump with a length of plastic tubing. The other is clamped to the cyclone. At the end of the sampling period, the openings on the ends of the cassette are sealed with a plug, and the cassette is sent to the laboratory for analysis. When sampling with filters, the laboratory is also provided with the volume of air sampled. This quantity is determined from the flow rate of the pump known from calibration and the duration of the sampling period. Whether you're using an air quality control system that removes the crystalline silica from the air or work in an all-wet shop, once the air quality is measured and falls at or below the allowable limit, individual respiratory protection generally is no longer required. However, standard practice calls for scheduled monitoring at least once a year to verify that the air quality remains within compliance levels.
If you have an all-wet shop and you're using the water properly and you have monitored to make sure that the levels are below the OSHA levels or perhaps even lower than the OSHA levels for silica, then you won't have to wear a mask. If the air system or the ventilation is working properly, it should control the silica levels and then a mask won't be necessary.
It goes without saying that air quality and water treatment systems, which then become the lifeline of protection, should be continually and carefully monitored to make sure they're always functioning at maximum levels. In addition to large systems that remove dust from major sections of a fabricating plant, vendors have developed a number of other dust capture tools, including portable collectors that can be moved around the shop as situations demand. These are particularly helpful in plants where only a minimum of dry cutting or polishing occurs. It's extremely important when monitoring air quality to check areas in which workers perform functions with these devices. In shops that are dry or partially wet, or where only sections of the facility are covered with air purification systems, these precautions should be taken to minimize exposure to crystalline silica. Wear disposable or washable protective clothing at the worksite. Shower if possible and change into clean clothes before leaving the shop.
You don't want to take it home because you want to limit your exposure to workplace exposure. And if you take it home, you'll have exposure at home or in your car, and your family also will have exposure. So we advise employees to keep their work clothes at work and to wash or shower before they leave at the end of the day.
Always wear adequate respiratory protection as specified by your company. When respirators are used, the employer must establish a comprehensive respiratory protection program as required in the OSHA Respiratory Protection Standard. Key elements of the program should include periodic environmental monitoring, regular training, selection of proper NIOSH-approved respirators, an evaluation of the worker's ability to perform the work while wearing a respirator, respirator fit testing and maintenance, inspection, cleaning, and storage of respiratory protection equipment. Post warning signs to mark the boundaries of work areas that may exceed the permissible exposure limits, PEL, for contamination with respirable crystalline silica. Workers should be provided with training that includes information about health effects, work practices, and protective equipment required for respirable crystalline silica. Do not eat, drink, or use tobacco products in dusty areas. Wash hands and face before eating, drinking, or smoking outside of dusty areas. Park cars where they will not be contaminated with silica and other substances. In addition, medical monitoring should be available to all workers who may be exposed to respirable crystalline silica. Such examinations should occur before job placement or entering the stone trade, and should include an X-ray and pulmonary function test to establish a worker baseline. Checkup should occur at least every 3 years. Workers should immediately report any unusual respiratory medical problems, especially a chronic dry cough and breathing difficulty.
When our staff goes out to look at silica in the workplace, we always ask employees, how are you feeling? How are you feeling? Any problems? And once in a while somebody will say to us, yeah, I have some pains here. I have pains in my chest or pains in my stomach, and we'll send them to a doctor. We have found several cases where employees have had silicosis.
We can't stress this too much too often. Protecting the workplace and employees from respirable crystalline silica and eventually silicosis is really a simple proposition. There is no cure, but with the proper equipment, training, vigilance, and continuing monitoring, you and your shop can be free of the scourge of silicosis. It's as simple as that. We asked OSHA's Nancy Newman to list the 3 most important things for an employee to remember in the battle against respirable silica dust.
Work wet, and work wet. That's the way to prevent it.
The foregoing video and the information it contains is provided as a public service by the Marble Institute of America, Incorporated. While the information and recommendations contained in the video have been compiled from sources believed to be reliable, the Marble Institute of America, Incorporated makes no guarantee or representations as to and assumes no responsibility for the correctness, sufficiency, or completeness of such information or recommendations, and further shall have no liability to any persons or entities with respect to any loss, liability, or damage alleged to be caused by the application of the video or the information contained therein.